The year 2025 is turning out to be one of the most intense and transformative periods in modern defense development, and among the systems quietly drawing attention behind closed doors is the F-3/4 F-1/4 F-degrees F-1/2 missile. Unlike flashy public unveilings or heavily marketed weapon platforms, the F-3/4 F-1/4 F-degrees F-1/2 missile has followed a different path, the one defined by controlled information, selective disclosures, and a steady trail of technical hints that suggest something far more significant than early observers expected. What makes the 2025 update especially interesting is not just improved performance numbers, but the philosophy behind the missile's evolution, which mirrors how modern cars are updated: smarter systems, modular design, digital intelligence, and adaptability rather than brute force alone. From the earliest concepts, the F-3/4 F-1/4 F-degrees F-1/2 missile was never intended to be a single-purpose weapon. Instead, engineers designed it as a flexible strike platform, capable of adapting to different mission profiles with minimal physical redesign. By 2025, this idea has matured significantly. The missile's airframe now supports interchangeable modules, allowing rapid configuration changes depending on range requirements, payload type, and guidance priorities. This is similar to how modern vehicles use shared platforms across multiple models, reducing development time while expanding capability. The result is a missile system that can be tailored quickly, without sacrificing reliability or performance. One of the most important updates in 2025 lies in propulsion. Earlier iterations relied on a conventional solid-fuel motor optimized for mid-range engagements. The latest version introduces a refined dual-phase propulsion system that balances efficiency and speed more effectively. During the initial boost phase, the missile achieves rapid acceleration, minimizing vulnerability immediately after launch. Once cruising, the propulsion system transitions into a more fuel-efficient mode, extending range without increasing overall size. This upgrade alone changes how the F-3/4 F-1/4 F-degrees F-1/2 missile can be deployed, enabling deeper strikes while maintaining a compact launch footprint. Guidance has also undergone a quiet but powerful transformation. The 2025 F-3/4 F-1/4 F-degrees F-1/2 missile now uses a hybrid guidance architecture combining inertial navigation, satellite correction, terrain reference matching, and terminal autonomous targeting. What sets it apart is not just the combination, but how seamlessly these systems interact. Artificial intelligence algorithms constantly evaluate sensor data during flight, adjusting the missile's path in real time to account for electronic interference, unexpected obstacles, or changes in target behavior. In effect, the missile drives itself much like advanced driver assistance systems in modern vehicles, making continuous micro-adjustments rather than following a rigid pre-programmed route. Survivability has become a central design priority. In today's environment, reaching the target is often more challenging than destroying it. The 2025 update introduces a reduced radar cross-section through subtle airframe reshaping and advanced surface coatings. These changes do not dramatically alter the missile's appearance, but they significantly lower detection range. Combined with an unpredictable flight profile that includes altitude variation and lateral maneuvering, the F-3/4 F-1/4 F-degrees F-1/2 missile becomes much harder to track and intercept. This is comparable to how modern performance cars use aerodynamic tricks that are invisible at first glance but dramatically improve handling and efficiency. Electronic warfare resistance is another area where the missile has seen major improvement. The updated onboard processors can now recognize jamming attempts and dynamically switch guidance modes without operator input. If satellite signals are disrupted, the missile seamlessly relies on inertial and terrain-based navigation. If sensor data becomes unreliable, priority weighting changes automatically. This level of autonomy reduces the burden on launch crews and increases mission success rates, especially in contested environments where electronic attacks are expected rather than exceptional. Payload flexibility remains one of the defining characteristics of the F/F3/4 F1/4 F F1/2 missile. In 2025, engineers have refined the internal bay to support a wider variety of warheads without structural modification. Conventional high-explosive, penetration-optimized, and specialized payloads can all be integrated using standardized interfaces. This approach mirrors how automotive manufacturers design engines that can accept different tuning packages without redesigning the entire drivetrain. The benefit is faster deployment of new capabilities and easier upgrades over the missile's service life. Accuracy figures, while officially undisclosed, are believed to have improved noticeably. Industry analysts suggest that the circular error probability has been reduced to a level competitive with top-tier systems globally. This improvement is not solely due to better sensors, but also smarter decision-making during the final seconds of flight. The missile now evaluates multiple impact solutions, selecting the one with the highest probability of success based on real-time conditions. In practical terms, this means fewer missiles are required to achieve the same operational effect, improving efficiency and reducing logistical strain. Launch compatibility has also expanded. The 2025 F/F3/4 F1/4 F F1/2 missile can now be deployed from a wider range of platforms, including mobile ground launchers, fixed installations, and certain naval systems. Adaptation kits allow integration without extensive modification, similar to how a new engine platform can be fitted into multiple vehicle models with minimal changes. This flexibility makes the missile attractive for forces seeking to modernize without replacing their entire launch infrastructure. Testing data from late 2024 and early 2025 indicates a strong focus on reliability. Engineers deliberately subjected the missile to extreme environmental conditions, including temperature fluctuations, high humidity, and prolonged storage scenarios. The goal was to ensure consistent performance regardless of deployment environment. Results reportedly showed a significant reduction in maintenance requirements and pre-launch checks, allowing faster response times during operational use. Another subtle but important change lies in software architecture. The missile's digital backbone has been redesigned to allow updates without hardware replacement. New targeting algorithms, countermeasure responses, and performance optimizations can be uploaded as software packages, extending the missile's relevance over time. This is perhaps the clearest parallel to modern vehicles, where over-the-air updates can improve performance long after purchase. In military terms, this approach dramatically reduces life cycle costs and keeps the system adaptable to emerging threats. Strategically, the 2025 F/F3/4 F1/4 F F1/2 missile fits into a broader shift toward precision and deterrence rather than saturation. Instead of relying on overwhelming numbers, the focus is on delivering guaranteed effects with minimal exposure. This philosophy aligns with modern military planning, where information dominance and precision strike capabilities often outweigh sheer firepower. The missile's design reflects this reality, emphasizing intelligence, adaptability, and survivability over raw speed or explosive yield alone. From a production standpoint, manufacturing efficiency has improved. Modular construction allows parallel assembly lines to work simultaneously on different components, reducing bottlenecks and shortening delivery timelines. Quality control processes have been enhanced through automation and digital tracking, ensuring consistency across batches. This industrial approach mirrors automotive production lines, where modularity and data-driven quality checks are standard practice. International observers have taken notice, even if official details remain limited. Defense analysts frequently reference the F/F3/4 F1/4 F F1/2 missile as an example of how modern systems blur the line between traditional weapons and intelligent platforms. Its evolution demonstrates that future missiles will not just be faster or longer ranged, but smarter, more flexible, and easier to integrate onto existing force structures. Looking ahead, the 2025 update is unlikely to be the final form of the F/F3/4 F1/4 F F1/2 missile. Development pathways already hint at extended range variants, enhanced seeker options, and deeper integration with network-centric command systems. The foundation laid in this version makes such expansions feasible without radical redesign. Much like a well-engineered vehicle platform, the missile's architecture supports growth, ensuring relevance well into the next decade. In conclusion, the 2025 F3/4 F1/4 F F1/2 missile represents more than an incremental upgrade. It embodies a shift in design philosophy, borrowing concepts from modern automotive engineering: modularity, software-driven improvement, efficiency, and adaptability, and applying them to advanced strike systems. The result is a missile that is not just a weapon, but a continuously evolving platform, capable of meeting current demands while remaining ready for future challenges. As more details emerge, it is becoming increasingly clear that the F3/4 F1/4 F F1/2 missile is not just part of the 2025 landscape, but the signpost pointing toward how next-generation systems will be built, deployed, and sustained.